Hi, my name's Sung. I'm the director of Sky Academy, and really this is where it all pretty much finishes off for our chapter on plane geometry. Last episode I looked at area. I kind of looked at perimeter as well, but I mainly looked at area of two-dimensional shapes. In this episode, what I want to do is look specifically at surface area and volume, but my main focus will be on volume of finding the volume of three-dimensional shapes. Common three-dimensional objects that you might find, all right, that are common to this course. But let me just quickly go through with you what volume is all about. So volume is really just the amount of three-dimensional space that a three-dimensional object contains or takes up, okay? So for example, if you have a container, right, or a ball, that's going to take up a certain amount of space in the world, okay, in physical space, right? That space is the volume that it takes up, okay? So that's basically what volume is. Surface area, on the other hand, is a totally different concept. Surface area is the combined areas of all the different surfaces that a shape has. So if you had, for example, a box, okay, and in that, so if you had like a rectangular box, right, then that box consists of the top, the bottom, the two sides, the front, and the back. So there's altogether 6 faces, yeah? And each of those 6 faces is going to be a rectangle. Well, the surface area of that box will be the sum of the areas of all 6 faces. Top, bottom, side, front, and back. Does that make sense? So that's really what surface area is. And I just want to make a distinction between volume and surface area. So to work out surface area, what is really helpful for you is to go back and have a look at the episode that we did last, all right, which was on area and perimeter. Because to work out the surface area, we really do need to work out the area of some common shapes. Yeah. This episode concerns itself more with volume. All right. So let me just explain to you how to find the volume of some common shapes. Now, there are all the shapes that you will be required to work out the volume for kind of fit into 3 main categories. Right? The first category is basically prisms. The second category includes pyramids. And the third category involves curved objects. All right? So let me go through each of those bit by bit. So let's start with prisms. All right. So prisms, you should be fairly familiar with prisms. You will have seen prisms in your junior years. So a rectangular prism, a triangular prism. When you see one, you know what they are, right? They're often times a little bit harder to describe or to define, but here is my best efforts at defining what a prism is. So a prism is basically a 3-dimensional object comprising of a polygon base, and I use the word polygon here just to kind of differentiate, for example, most prisms with cylinders, right? Cylinders have a circular base, which isn't necessarily a polygon, and a cylinder isn't necessarily a prism, all right? Although it's a prism-like structure, okay? But a prism is basically a 3D object comprising of a polygon base that has a uniform cross-section throughout, where the cross-section is parallel to the base. Got it? That's probably my best effort at kind of explaining what a prism is, right? So here I've got an example of a prism, right? You've got a polygon base, and that base here is a pentagon. Now, just because the base isn't resting flat on the ground doesn't mean it's not a base, right? So the base here just means where the cross sections are. Now, can you see that the front is a pentagon? The back is a pentagon, and all the way throughout the shape, if you were to slice it up parallel to the base, you would have cross sections of pentagons that are the same size and the same shape as the original base. Do you see that? That's what makes it a prism. Now, to work out the volume of a prism, right, you basically take the area of the cross section. So in other words, you've got to find the area of the pentagon in this particular case, and then multiply by the height. The height being the length from one base to the other base. Got it? That is the volume of a prism. Okay, so basically you find the area of the base times by the height, the perpendicular height. A pyramid, on the other hand, is slightly different. Okay, so where you've got a pyramid is a three-dimensional object comprising of a polygon base, right? That ends at a vertex. So it starts with a base. Here we've got 1, 2, 3, 4, 5, 6, 7. It's a heptagonal base ending at a vertex with cross sections that are parallel to the base that are similar throughout. So in other words, they're the same shape all the way throughout, not necessarily the same size, because as it gets close to the vertex, the cross sections are going to get smaller, but the cross sections nonetheless are going to be similar. All right, so in other words, the same shape but different sizes to the original base at the bottom. Okay, and where that is the case, to find the volume of a pyramid, you basically take the area of the base, or in other words, the area of the heptagon at the bottom, times by the perpendicular height, not the slant height, but the perpendicular height, and then you divide by 3, or so it's 1/3 of the area of the base times the perpendicular height. Got it? Cool. So that is the volume of a pyramid. The last category, right, deals with curved objects. Let me start with the three basic curved objects that we're going to be dealing with are cylinders, cones, and spheres. Now let me start with cylinders. Can you actually see that a cylinder, while it's not a prism, is a prism-like structure? In other words, it's got a base, which is a circle, and the cross-section is uniform throughout the shape. Can you see that? So you would expect the formula to be exactly the same. So the volume of a cylinder is the area of the base times the height. The area of the base is a circle, so it's pi r squared, which is the area of a circle, times the perpendicular height. Got that? Now, to work out the surface area of a curved object like this, what we can do, this is just as an aside to help you work out the surface area, is can you see that the cylinder comprises of two flat circles, one circle on the top, one circle on the bottom, they're flat. And then if you were to unroll the curved surface, you can unroll it so that it becomes like a flat rectangle, right? Now the length of that rectangle would be the circumference of the circle. So basically, you've got a rectangle, length is going to be 2 pi r, which is the circumference of the circle, times by the perpendicular height, which is 2 pi r h. And then you basically add the two circles together, which is pi r squared. So you got 2 pi r h plus 2 pi r, and that is the surface area of a cylinder. Okay, but what I'm mainly focusing on is the volume, which is area of the base times the height. So the volume of a cylinder is pi r squared h. The volume of a cone, right, is going to be similar to the volume of a pyramid, because can you see that a cone is a pyramid-like structure, except for the fact that the base is not going to be a polygon, but it's going to be a circle, right? So the volume of a cone is going to be 1/3 the area of the base times the height, and the area of the base is going to be a circle, so it's pi r squared. So it's 1/3 pi r squared h. Can you see that? Good. And the surface area of a cone is going to be slightly more complex, right? But basically, I'll just give you an idea of how to work that out. The surface area of a cone consists of a flat circle on top, and the curved bit, when you unfold it, right, is going to be a sector, right? So you're going to have to find the area of the sector of the curved surface, which when unfolded becomes a sector, plus the area of the smaller circle at the top. Add the two together and that will give you the surface area of a cone, okay? So yeah, there's that one. And then the final one is basically a sphere. The final curved object that we need to find the volume and surface area of is a sphere. And this just really comes down to remembering the formula for this. So the volume of a sphere, 4 on 3 pi r cubed. The surface area of a sphere, 4 pi r squared. Okay, so just remember those. You might even, my understanding is that you will have formula sheets from now on. So you might even want to refer to the formula sheet that this will be on. Okay, so there you have it. That is how you find the volume and the surface area of 3D objects. Thank you very much for watching.